Hi, I'm Damon Cortese, a Principal Developer Advocate for Analytics on the EMR team at AWS, and I'm here today to show you how to get started with Amazon EMR Serverless. EMR Serverless is a new deployment option for Amazon EMR, available in preview today, that allows you to easily run your choice of open source big data frameworks without worrying about or managing clusters or servers. It's simple to use, fast, and saves costs by paying only for the compute time and resources that you use. In this demo, I'm going to show you a couple things. First, how easy it is to run a Hive job using EMR Serverless APIs. You just provide your Hive query and EMR Serverless will dynamically scale at each stage of your data processing application. And then I'll also show how to configure your application to use pre-initialized capacity so your jobs can start instantly. Let's get started.
We're going to go ahead and create a new application on EMR Serverless. In this case, we're creating an application where we can run Hive jobs using EMR Release 5.33. If we use the get application command on the application we just created, we can see that it is in a creating state. Once the application is in a created state, we can go ahead and call start application. If you're using pre-initialized capacity, which we'll talk about later, this will create a warm pool for your application so workers are ready to receive workloads instantly. I've done a little bit of prep work ahead of time, like creating an IAM role for my job and uploading this simple Hive script to S3. The Hive script does a count star of records from the Open Data NOAA GSOD PDS table. By default, EMR Serverless uses the glue data catalog, and the NOAA table here points to an open data set from the registry of open data on AWS. Now that our application has started, we can go ahead and run our job. Later on, I'll also show how to pre-initialize capacity so jobs can start instantly. For the Hive application, we provide our SQL script on S3 for the entry point of the Hive CLI job driver. We can also send our logs to S3, and those will populate as the job runs. Once we submit the job, EMR Serverless automatically provisions the resources necessary to run your job. There's nothing else for you to do but sit back and enjoy a cup of tea. EMR Serverless schedules the job for you and will switch to a running state automatically once capacity has been allocated. While the job is running, you will see logs begin to populate in S3. There's timeline data in case you want to run the TES UI to interactively debug your job, and as the job progresses, you can also see the state of mappers and reducers. This information is in the Hive Manager prefix in S3 and the standard error logs. Here, we're just copying down standard error, and we can see the current state of the mappers and reducers for our job. If we refresh the logs, we can see that the job is finished. It took just about 4 minutes, and we can see there's one row of our count query. Let's fetch the standard out log to see what the count of weather records is. This is just fetching the data from S3 again, unzipping it, and looking at the output. We can see here that there are just over 4 million records. Awesome! That was pretty easy. When the job is done, the resources you used are automatically decommissioned. Now, let's talk a little bit about pre-initialized capacity. While EMR Serverless can automatically request more capacity with increasing workloads, sometimes you want to ensure you have a certain amount of capacity pre-initialized. This might be so jobs can start instantly, or if you have interactive workloads like SQL editors or EMR Studio. You can define your initial capacity when creating your application, or you can even stop an existing application, update the capacity, and restart it. In this case, we're stopping our Hive application, and we'll see here the initial capacity of the application has a worker count of 9, and we're going to update that with the update application command to specify a worker count of 20. Then we'll start the application back up. Now, your pre-initialized capacity is ready whenever you want to start your jobs. It's also maintained when all jobs are complete so they can start quickly. When you stop your application, the capacity is decommissioned. This is useful from a billing perspective, and EMR Serverless provides you the ability to balance performance and cost based on your requirements. So that's EMR Serverless on how to run a Hive script and how to pre-initialize capacity.
So that's it. In this demo, we showed how you can easily run Hive queries with EMR Serverless and how to configure your application with pre-initialized capacity for instant start times. We built EMR Serverless to make it simple to use for data scientists, data engineers, data analysts, and really anybody that wants to run big data workloads. There's no servers to manage, and you get the latest open source releases within 60 days of release. You can use EMR Serverless for auto-scaling multi-tenant clusters for teams, scheduled data pipelines, or interactive workloads like notebooks, SQL editors, SageMaker Studio, and of course, EMR Studio. Next time, I'll talk about how you can easily run PySpark jobs on EMR Serverless and how to use the Spark History Server to debug your job while it's running or once it's all done. Have a good